All right, so let's try some of these two proportion problems. What you're going to need are the blank pages for the notes. You're going to need your handy dandy graphic organizer because it has the formulas. And then you might need that T-table that we printed off yesterday so that we can look up those Z-star, the critical values on that bottom row. Roof, roof to you too, Lily. Roof, roof, roof. Right, we're excited in here. Woohoo! Roof, roof, roof! Ah! Life is crazy! All right, here we go. Hush. A group of intro stat students was interested in how many students were happy with their choice of university. So they went out and they surveyed, do you plan on returning next year? And they got their responses, yeses, nos, maybes, and they put it in the chart based on gender. We're going to find with 99% confidence the true difference of opinion between male and female students. All right, so here's how these start. You define what it is we're going to be capturing. All right, so we're capturing P1, which would be the true proportion. Let's start with males because they're first in our chart. True proportion of males. Ooh, interesting. And it says true difference of opinion. So you can go either way you want on these for your responses. I'm going to focus on the yeses. True proportion of males who say yes to coming back next year. All right, so then P2, that'll be our true proportion of females. Wow, that's not how you spell proportion. Proportion, there we go, of females who say yes to the dress. Just kidding. Who say yes to coming back next year. Next year. All right, so we got to check those conditions. When you're doing free response, you can put conditions off to the side. They can take up the whole flow of your workspace. You do you, boo. All right, I usually write kind of large, but if I visualize my space before I get too far, like these little dotted lines, then I might help control myself. So I'll put my conditions here. I'll do my formula work over here. And then down at the very bottom, I can do my conclusion. That ought to be enough. All right. Okay, so your conditions, plural, there's 3 of them. The first one is random. Did they randomly select people? Let's go back and see. Aha, random sample. Yeehaw! Woohoo! Arr! We are good. So we could say random stated. All right. Condition number 2, discount normal check, paging Jack from Stat Farm. Jake. His name is Jake. All right. So for the normal check, we got to do both. So this one takes just a second. We got to do N1, P1 greater than or equal to 10. And then we got to do N2, P2 greater than or equal to 10. So let's come up here and check things out. We had males, females. We had 211 out of 275 that said, yes, I'm coming back next year. So 211 divided by 275, I'm typing that into TI Jill real quick. You get 0.77. All right, so that is our first sample, P hat 1. Our second sample was the ladies, 141 out of 182. Said, yes, I'm going to come back next year. I love it here. This is such a great university. So that, it's also 0.77. So now I'm questioning my life. I probably need more decimals. So I'm going to say 775. And let me type in the guys again. Okay, so we'll do 0.767 versus 775. Yeah, we don't want to round too soon because then, issues. Okay, so back to our conditions. Our N1 was for the males. We had 275 males. And you know what? This chart actually has everything done for you. I'll show you what I mean in a minute. The proportion was 0.767. You could type that in, or you could just know, that was how many that said yes. So that was 211, right? 211 said yes. Same thing for group 2. This is for the females. How many yeses did we have, right? How many successes? We had 141 successes. So we're good on successes. Then we could check the failures. So that's N1, 1 minus P1. That's got to be at least 10. So when you go through and you check the males for N1, we had 45 that said no. So that could be your quote unquote failures, or the other half of things. I guess we could include the 19 even then. So we are totally clear. Everything is greater than or equal to 10. So let's see, 45, 55, 65. So that's 64. And then for females, 32 plus 9, so 32, 41. All right, so a big old yes, right? We are approximately normal. We have at least 10 successes and at least 10 failures. Okay, and then the third thing, we got to make sure we didn't sample too many people. I don't know how many students are at this university. Oh no, so we're going to have to assume. All right, so for our 10% condition for independence, we need to assume at least 2,750. So 2,750 men. And 182, slap a 0 on it, women in population at this university. Ooh, forgot to label. This is our independent check. All right, that's safe to assume. If it's a large university, we're good. It didn't say that it was a small university or anything, so we should be solid. All right, so now it's time for the formula. We are trying to capture the difference between males and females. We don't know what the truth is. All we have is a p-hat, right? All we have is an estimate. So we've got our p-hat 1, males, was 767 minus. Our p-hat for females, 775, plus or minus. And, ooh, this one's a little different. 99% confidence. So, if you go and you look up your Z-star on this sheet here, this table, Z-star for 99% is 2.576. 2.576. 2.576. And if you're confused on what I'm doing, I'm just here on this graphic organizer, right? We went through our checks, and now I'm here in the formula zone. So now it's time for that giant square root. Ah, the standard error. I cannot fit that right here. That's a little dangerous. So I'm going to bring it, unfortunately, right below it. I apologize. So times that standard error, and I'll draw an arrow. All right, so my standard error. Okay, so we do 0.767 times 1 minus 0.767 all over 275. So that's for males. All right, so that was the proportion of males. Stats diet. Then we got to do the females. Females was 775. 1 minus 775 all over 182 females. Ta-da! Typing that into the calculator, not like that, I'm not gonna. T.I. Joe's got it programmed in Stat World. So grab that calculator. Head on over to Stat World Tests. And you're scrolling. Let's see. A would be for one proportion, but we clearly have two. We have males, females. So I'm going to go down to B-boy, 2 prop Z int. Once you're in there, it's going to ask for details about your sample. The first sample was males. We had 211. Uh-oh, Hubs is calling. Put you on pause. Our first group, we've got 211 males out of 275 that we surveyed. The next group is our female numbers. We had 141 that are coming back next year out of 182. Then T.I. Joe wants to know, hey, how confident do you want to be? I want to be 99% confident. So I'm going to put in a 0.99, right? That's what the problem wants. And then calculate, and it's going to run it for us. Woohoo! Yay! Just to verify, right, that your p-hats were right. Yeah, p-hat looks good. Okay, so our answer was negative 0.11 to positive 0.095. So I'll say 10%. So negative 11% to positive 10%. I'll tell you what that means in a minute. Let's go ahead and get it written down. All right, so this equals negative 0.1108 to negative, might as well just say 10%. Ooh, that was positive. Positive. That was a positive. There was no negative there. All right, so it turns out the difference between males and females could be negative, meaning P1 is, nope, P2 is the bigger number. Or it could be positive 10%, which means P1 was the bigger number. So in other words, our interval is saying that there's no difference, right? Notice how 0, our hero, 0, is captured on this interval. If 0 is captured on your interval, that means there's no difference between your two groups. So as far as the opinion, right, the true difference of opinion, I would say statistically there is no difference. You might argue, yeah, it's kind of different. Oh, they're very similar. Yeah, but statistically they're so close that we would say there is no difference. All right, so our conclusion, we have to sprinkle in all of the fancy pants things here. We are orange. We are 99% confident. The true difference of opinion between male and female is in the interval negative 0.11 positive 0.10. In other words, there is no difference between the groups. All right, there's no difference. You might say, well, there's more negative than there is positive. Who cares? Right? This interval is showing you all the possibilities. It's not necessarily saying more negative than positive. Since 0 is captured, that means there's no difference, right? 0 is a possibility. There's no difference. So statistically, I don't have the evidence to conclude anything otherwise. All right, so that's it for this page. I'm going to go ahead and make the answer keys for the other 2 pages so you can spot check yourself. And hopefully I'll see you later in the chat if you have any questions. Bye-bye!